Bismillah Rahman Rahim. Assalamu alaikum. My name is Asim Ali Khan, and I'm teaching computer science and IT since last 18 years in different in different renowned schools of Lahore. And today we'll be discussing about logic gates. Logic gates is one of the very important topic taken from computer science AS. It also has a progression to A2 as well. We have a progressed model of logic gates in A2 as well. Logic gates is a very important topic as far as the concern of our examination pattern, one, and number two, in our real life. Generally, different students of computer science usually ask me, why do we need to learn logic gates? Why? We are here to learn programming languages. We are here to learn different tactics of using computers. Why do we need to learn logic gates? Basically, I always used to say, basically, computer science is not a natural science. Like mathematics is a natural science, physics is a natural science, chemistry is a natural science, computer science is a combinational science. Now, what is mean by combinational science? Combinational science means a combination of mathematics and physics. Mathematics allow us to learn different ways of calculation. Calculation is very important part. If we are drawing any graphics, we need calculation. We can't create a graphics without using x-axis, y-axis, and z-axis. It means we need calculations. On the other hand, why physics? What do we do with the physics? Why we need to learn physics in computer science? Because physics allow you to learn about current. And we all know that computer is basically based on 0 and 1. 0 means off, 1 means on. So when we talk about zeros and ones, it means we need to learn current. And on the other hand, when you are selecting your prospect careers, so when we are selecting our prospect careers, so what we'll do, we have different options. We can go for software engineering. We can choose hardware engineering. And if you are choosing hardware engineering, you need to learn this because we need to build different blocks. Let's say, this is it's a TV remote. We need to learn that how its circuit working, how its sleep button working, how this red button working. So this is what the use of logic gates in our real life. As per our syllabus, we have to learn six different logic gates in AS level. Number one, we start with the basic logic gates, and then in the next lecture we will be discussing the advanced logic gates. Number one is a not gate. It's a gate. In a while, I'll tell you what is meant by the gate and how we use them. Number two is AND gate. Number three is OR gate. So these are three basic gates we have. Now, when we talk about building blocks, when we talk about circuit design, my emphasis on the design part. That design means we should be using some shapes. There must be some symbols, because if we are using the word design, it means that we will be using few shapes also. Now, if we want to learn about not gate, how we can draw that, uh, let's say A, then we have a line, then a symbol, and then this X. Now, what is meant by all of that? I'll make few annotations here. First of all, if we talk about this A, what is this A? Usually, the students, those who have learned logic gates, the basics of logic gates in O levels, they usually call it as input. Few call it as variable, and few So few called it as not, and what I want you to call it, we will calling it as switch. Now it's the same switch which we are using on our switchboards. It's this is the same switch. Now the second part, because since we are annotating it, the second part is this one. This is my gate. Right now it's a NOT gate. And in the end, we have this X. X generally is called as output, and what we used to call it in A level, especially because examiner always expect a better knowledge when you are in the A levels. So we will be calling it as device. It could be a bulb, it could be a television, it could be a fan, it could be an air conditioner, anything. That output is something which gives practically as like it gives output. So when we talk about not gate, how we can write in boolean expression. When we are using boolean expression, we have already studied about boolean expression in chapter 1 and 2. So when we are talking about boolean expression, how we can show not gate, not gate will be showed as a bar, that will be a not, or we can use a complement this way. So this is the way we can use a not. And what does that mean? Not gate is doing what? Not gate is basically used for inverse. Inverse what? See, I'm using my remote control, television remote control again. This red button, this red button. When I press it for the first time, what it do? It will be converted into 1. 1 means my television will be on. If I'm pointing this remote to my television, if I'm clicking on this red button, it will be switched on. If I am clicking it again, it will be converted into or inverted into not means 0. Not means not 1. Inverse of what? Whatever I am getting through this switch, this one, this switch, whatever I'm getting from this switch, that would be converted or inverted. Now the second gate is AND gate. AND gate is very important gate. All gates are important, but AND is it's different place. So how we can create a shape for that? AND gate, A and B. Now you can notice that we have two switches. Like when we are working with NOT gate, we only have one switch, but when we are working with the AND gate, we have two different switches. Switch A and switch B. And what would be the shape for switch for AND gate? It's a D-like shape. This is my AND gate. Now the output, which is actually a device, X. Now why we use AND gate? NOT gate was pretty simple. We have discussed that. We can use it like with the on-off button or something. But why we are using AND gate? AND gate is basically used in if I give you the real-time example from our real life, like a ceiling fans. Whenever we are talking about ceiling fans, if we want to switch on our ceiling fans, we have two different buttons for that. One is a regulator, the rotary type of thing, and the second one is a switch. See, I have to switch on both switches. The regulator, it should be turned on, and on the other hand, the switch, it should be turned on. One. If both values giving is 1, it means that we'll be getting the output. And the output in the ceiling fan case is that your fan start moving, and that's the output. Now, how we can represent AND gate? It's more or less like mathematics. AND gate can be represented as A dot B. Or the second way is we can write it as AP. But please Yes, but please don't write as a multiply by b, because this multiply sign looks like x. So we don't recommend that. Even examiner don't recommend that. So this is the wrong way. We are not doing this. And if we are writing like a dot b or ab, so it means it's a multiplication. It's a simple multiplication. Multiplication of what? Multiplication of bits. Multiplication of A and B. And X is our output. After the multiplication, whatever I'm getting, that would be considered as our output. Now, the third gate. Third gate is an OR gate. When we are talking about OR gate is like A, B, and again, you might have noticed that now again, I have two different switches as an input, and its shape is like this, and X is my output. Now, A, B, or is used as what? How we can represent in Boolean expressions. So, if we want to represent this statement, this gate in Boolean expression, so what we do, we write it like A plus B. It means it's uh, it's an addition. So it's an addition. Addition of what? Again, addition of two bits, A and B. Now, I'm just scrolling my screen. I hope you have already write that. So, like this. Now, the next important thing is what we do with these shapes. We made them beautiful, excellent. Now, the next part. The next part is that we have to make truth tables. Now, what is meant by truth table? Truth table means all the possibilities. Possibility means, again, my remote. Possibilities of this red button. How many possibilities we have for this red button? Two only. One, switch on, and again, switch off. There is no any other possibility. So, if we want to document that possibility, we will be using a small formula. What is the formula? Formula is like 2n. Why 2? Because our binary language only support 0 and 1. That is why 2. And n means what? N means number of switches. Number of switches. Yani number of inputs. Now, if I talk about NOT gate, I'll made it again like this. ये हमने बना लिया. Now 2n. 2n means how many switches I have? I have basically only one switch in this. So 2 power 1. It means I have two possibilities. Now, how I can create this truth table? A and X. A will be considered as our input, the switch, the input, and X will be our output. Now, tell me, what is the default state of any device? Default, we all know what is meant by default. What is default state of any device? It's switched off. When we are taking a television from the market, when we are buying air condition from the market, it's switched off. So it means we have to write 0 in the start. This is 0. And then 1, because we have only two ही possibilities है ना, 0 and 1. So we have started with 0 and then 1. Now we all know, we have discussed about that NOT gate is basically inverse. 0 inverted into opposite, it means it would be 1, and जब 1 को करेंगे that would be 0. So it was pretty easy. Now we'll be talking about AND gate. When we talk about AND gate, now I'll scroll my screen again. Now AND gate. I'll make my AND gate diagram again. A, B, this, and the D type shape, and then we have X. Now, how many switches we have? One and two. Now we have two switches. 2n means 2 power 2 means 4. It means now we have four different possibilities. Now how we'll create the possibilities? A, B, X. X is my output, A and B is my input. Now, how we can use that? We have to make sure that every group comes only once. It shouldn't be repeating. Group means A and B, both values together. So for that purpose, what I do, I'll be dividing the output, the answer of 2 power 2, 4 divided by 2. Answer क्या है? 2. It means in A, what we have to do? 0, 0, 1, 1. The combination is 0, 0, 1, 1 because it's 2. If I divide 2 again with 2, 1. It means 0, 1, 0, 1. See, not even a single group is repeating. And the second thing is that the minimum value is a 0, which is a default value, as we have discussed earlier. And the maximum output is 1. It's in the end. Now, as we have discussed earlier, that AND gate is multiplication. So we are multiplying these two values. 0 multiplied by 0, 0. 0 multiplied by 1, 0. 1 multiplied by 0, 0. And 1 multiplied by 1, 1. So that's how we can solve it. अब जरा same one thing bring back into your mind the regulator and the switch on for the ceiling fan. If both switches are off, this is basically my switch and this is my regulator, the fan regulator. If both switches are off, this is off, this is off, the fan will be running, moving? No. If switch is off but regulator is on, my fan is not working. If switch is on but my regulator is off, no. When I'll be getting the output? Basically, I'll be getting my output when the both values are 1. All right. So I hope it would be very helpful for you. We'll be continuing in the next lecture with OR gate and with NAND, NOR, and XOR gates. I hope it was helpful for you, and it would be helpful in your as far as examination patterns and as far as knowledge wise. See you inshallah. Thank you very much. Allah Hafiz.